So we'll go ahead and get started. So first off, do a few housekeeping and introductions. So Tracy Bills, SCS engineer. I'm also the executive director for CRRA. I'm happy to participate in this webinar. A few housekeeping items. If you look at the top of the screen, it says view active cameras. You can actually view everyone, view who's talking, view active cameras. So if you only want to see the presenter, you can do that as well. Please make sure that you're muted. It helps, although I can mute you. So if you notice somebody mutes you, it's because we can hear you. We're going to have 4 presenters today, Michael Timpane, Brent Hildbrand, Tim Dewey-Mattia, and Adam Schaefer. And so before we dive into the presentations, I wanted to introduce Jeff Epstein. He's with the Carton Council. He's the one that put together this MRF technology webinar that we're super excited about. Just a quick thing, each presenter will have about 10 minutes. And then if you have any questions, put them in the chat box and we'll be monitoring that. So with that, Jeff, I'm going to hand it over to you.
Tracy, thank you. Good morning. Just a minute of background here. As Carton Council, we've really enjoyed and tried to have a box seat on robotic sortation and artificial intelligence. As it's emerged, we have a vested interest in trying to improve or do what we can to make sortation more efficient. We've really been an early supporter of robotics as it's gone through its growth pains. And we thought that it's just really a good idea to talk about what's worked, what hasn't worked, where we are today. As a trade association, we're agnostic on technology or particular brands. We just want to see, we'll defer to whatever a MRF, prefers. We just want to see progress. So that's why we're interested, and that's why we really, appreciate the opportunity to be part of this. Our first speaker today is Michael Timpane. He's Vice President and Principal of Resource Recycling Systems, and I'm sure many of you know Michael. I view him as part MRF engineer, part visionary, part technologist, part industry statesman, and overall nice guy. And I always learn from Michael, whenever he presents, and he's always makes me think. So with that introduction, I'll hand the floor over to Michael and let him take over.
Okay. All right. Tracy, what can you see? Hi, this is Michael Timpane. Okay, thank you for that. So I'll go ahead and share my screen now, everybody. Can everybody hear me okay? And can you see my screen?
Yep.
Okay, let's start. So I'm here kind of to give you, I'm Michael Timpane from RRS, an Ann Arbor company. However, I spent a good half of my career on West Coast matters and half of my career on the East Coast matters. And I started my career in California and was a member of CRRA way back in the day. It's really good to be back. It's really good to see faces. Had a chance to visit out there recently. Bears on this presentation a little bit, but it's good. So my presentation is sorting at MRFs, a lesson in evolutionary volatility. And I'll talk about that a little bit. My firm, we are recycle.com. We spend most of our time thinking about recovery, and of course we work with many different groups, including the Carton Council, some of the equipment manufacturers, many municipalities, but really laser focused, kind of a boutique supply chain, recycling supply chain type of firm. So I'm going to talk about change in volatility a little bit and kind of set our speakers up that's who you really want your answers from. And I have a few notes on sorting, a few notes on artificial intelligence, excuse the artificial for artificial there, but a few notes on that and we'll go from there. So what is evolution of volatility? Well, it's a fractal time space. What that means is, in biology or in business, it's where things speed up at a rate where change is imminent, and it can go in fast directions in both ways, both positive and negative change. And since 2018, we've done nothing but experience that. And it just hasn't been COVID, which we all know about, but we also experienced 10-year market highs and lows, based a little bit on the China and Asia bans. We've also experienced increasing environmental angst and a recognition that some trends, ocean plastic pollution, global warming, are real. We've gone through unprecedented economic crisis and lockdown, but also a rapid recovery. We've further seen generational shift in preferences, which have pushed people out of the marketplace as much as COVID did. Civil disruptions, disorderly elections, and all of a sudden a rapid recovery flushed with cash and cash from brands moving into the recycling space, and now inflation. On and on. This has been a short term, less than 4 years. And what has it done to us? Well, it's changed our life. You hear terms like stay at home, away from home, essential designation for recycling, the value chain itself. We've seen recycling program disruptions and its impacts, contract challenges. I don't have everything listed here. We've seen divorces go up, labor shortages, brand involvement, never before, a flurry of new legislation across the East and West Coast, major acquisitions and site consolidations amongst the largest players in the industry, and a reindustrialization of domestic end markets. And that's only been in 4 years. And those things don't go unnoticed in the larger context of sorting. We were already moving in a direction, but it's pushed us out of need and out of the sense that now's the time. And it shows up all over the supply chain, right? The larger supply chain, transportation, how there have been orders canceled. There's backlogs. It's all occurring now. It's been occurring at least since June. One of the things that really impacts our industry, West Coast sea containers, you can still get one at 5,800s, have risen fourfold. And really, you could get sea containers 4 years ago for less than $500 on some backhaul routes when they were going to China. And even getting a sea container is hard. It showed up in other parts of the value chain for different reasons, but it's still there, and it's fractal in that same sped up way, positive and negative impacts to what's going on. Aging population, quality of life. It affects everything in the production and collection systems through end market deliveries, and responses have to include technological answers. In our supply chain alone, you've seen the headlines. You follow the same trades I do. Besides the essential nature of recycling, garbage and yard waste are more essential. So sometimes recycling's got pushed to the sideline because there's no labor. Large cities in the last 2 months have started to pause or go to every other week. There's a shortage of actual truck and truck parts. There's a shortage of computer chips, which we all use in our plants. The export shipping, especially from the West Coast, especially California, has been seriously affected. Space is tight, bookings, and in Canada, they even have it worse than we do. So we see it cascades down, and now it impacts all the way down to 20,000 some odd MRF sort laborers that populate our plants through North America. In a recent article, and the organized labor was talking about this, and there's been a rapid exodus from the industry of sorters because they're, in his words, tired of disrespect and poor working conditions. And MRFs, by and large, our poor working conditions have actually become less desirable, not because of those working conditions, which some people enjoy, like the industrial setting, like that they're doing something good for the world, but also because of preferences. It's an isolation that comes from the sound. It's not being able to integrate with your social media platforms, be in touch with your friends. The new generation of folks coming up find this to be intolerable. So you're seeing this push out of all the industrial trades, with MRF sort laboring being on the lower end of that in terms of desirability. So in many articles over and over again, and some of the people who are going to be on this, turnover has been greater than 100% a year. There's been high wage and benefit increases. MRFs are reporting almost universally serious labor shortages, and all these work conditions have contributed to that. One thing to know, it is a very dangerous job. As much as we may think we keep our employees safe, we haven't solved everything, and compared to most other industries, we still have a lot to solve. Our accident and incident rate, 1 in 20 MRF workers will be injured, 40% more than the average manufacturing job, and at least 34 MRF workers have died in the last decade on the job. It's not something to be proud of, but it further exacerbates the fact that having manual sorting in a plant is very difficult. So what can we do about it? And I'm here to posit that intelligent or positive sorting. Positive, and Ogden Nash called it the act of commission, not the act of omission. You're actually deciding to do something. It distinguishes, selects, and then it pulls and isolates a desired or undesired object from a material stream by shape or color or marking or chemistry or material composition. So this intelligent sorting, or the positive sort, you're deciding to do something. And when you decide to do it, if you do it correctly, you're going to get your highest level of quality. You're going to actually come close to getting the best sort possible. And I have a comparison on the right-hand side just to set this up. What can the average positive sorter who's intelligent, what can they do in a recycling plant? And if you look at the top, a MRF sorter, realistically, for over an hour time, if you do time motion studies, can do 60 to 80 sorts a minute, 80 being on the high end, 60 being on the high average end. The number of different kinds of sorts they can do is unlimited, except for the residence time on the belt. If you wanted to do a lot of sorts, you'd have to slow down the belt, but you can recognize as many as you want and you can get to them. The current limitation is that MRF sorters are becoming unreliable in being able to staff a full plant, whether or not they're from third-party sources, or the plant tries to staff them themselves. I've heard some MRF operators in the last 2 weeks tell me, it doesn't matter what I do, I'm offering educational benefits, bonuses of $3,000 to $5,000. I just can't get anybody. The second one is robotic sorts. Robotic sorts have really improved. They started out about 45 or 50 sorts a minute. They've gone up to 75. Yesterday, I was talking to a large user of robots who told me they were getting upwards of 75, 80, which was very positive, and we'll hear a little bit about that. The number of sorts they can do is flexible. It's kind of limited, maybe 3 to 6 at the very most. They can actually do more because they're recognizing different kinds of objects, but pulling all those different objects off and finding space for them in one area of a belt would be hard. And what are their limitations? Well, the hand of the robot, or the attachment that picks up the material, or the sweep arm, that has a limit in dexterity. It really isn't opposable thumbs. really isn't the evolved hand, human hand. So almost all MRF operators are still reporting high miss rates for the current fleet, although new units coming out are getting better and better at that. And in terms of optical sorters, and I want to make this designation, robots and optical sorters are close cousins. They're both positive sorts, where you are selecting, you're going through these same states where you distinguish, select, isolate, and start grouping like items together. It does go a lot faster. It has a limited number of sorts it can do, requires high volume, and you have issues with it. There's some misdirection of high revenue materials because of phenomenon like parachuting and that some large mass type of materials possess. So this intelligent and positive sorting, this comparison, when it comes down to it, the benefits of both 2 and 3 robots and optical sorters have now, in this fractal time, become a necessity whenever plants are being designed, retrofitted, built. The onus is, how can we replace something that is unreliable, could be dangerous, with something that will be much more reliable, and what's the efficiency, what's the trade-offs? We'll hear about that.
Michael, I have you 2 minutes.
Okay.
Time flies.
So I'm not going to go through all these things. I'll just do a couple of things here. It's been 15 minutes already.
13 and a half. Yeah.
Okay, good. So a couple of notes. The fleet of optical sorters has more than doubled since 2018, and the robot fleet is over 100% higher than 2018, and it's scheduled to double again in less than a year and a half. So we'll go from 10 installed in 2018 close to 500 in just about 2.5 years. There's a semblance of Moore's law when it comes to robot sorting. Firms offering robots have increased to 7 major companies from just one, Amp, who was really out there first. And there's been high funding in research. But it's same things happening on the optical sorters. I just wanted to make that point. In the future, we'll see standalone AI units that measure composition, branding veil packages for value. That's already occurring. Some robots qualify as being good for mill acceptance. There'll be a comparative use of AI before and after, and mass balances on each material line in MRFs, and so forth. The future is really bright, and we're moving extremely fast. And the point of all this is to set the stage for each one of our speakers. So without taking much more of my time, I'll answer questions later on these big trends, but I'll turn it back over. Thanks a lot, Jeff.
Yeah, Michael, thank you. If anyone has questions for Michael, just put them in the chat box, and then we'll address, or try to address, as much as we can at the end. So our next speaker is Brent Hildbrand. He's Vice President of Recycling at GFL Environmental. And Brent really is a true pioneer with robotic arm technology for the MRF environment. He was involved with probably the first, or among the first, that were utilized in Denver. So I thought he'd be great to have, as well as, have the perspective of a large MRF operator. So with that, I'll hand it off to Brent.
Great. Thank you, Jeff. Appreciate it. And Michael, that was great information as usual from you. So thank you for that too. A little bit of background for me is I've been in the business, waste and recycling, for over 25 years now. Most recently, I guess, I built a processing operation from the ground up in Denver, Colorado. In building that operation, we basically started from scratch. And in starting from scratch, I've done every position in a MRF. So, I've sorted, I've maintained machines, I've been inside of balers, loaded train cars, run a scale house, loaded the system with wheel loaders. So I think I have a bit of a unique experience from that perspective. Just one of those things you have to do when you're starting a business like that. My current role is Vice President of Recycling for GFL Environmental for the United States. And I have a counterpart that handles all of Canada. His name is Stephen Miranda, and he and I probably talk 2 or 3 times a day. But GFL Environmental, if those of you who are not familiar with us, we are the 4th largest waste and recycling company in North America. GFL stands for Green for Life. Really, it's a great brand, and it's a great fresh look on the industry from my perspective, with very, I guess, visionary management at the top. One, the sustainability side is very important to us. So there's a little bit about my background. I appreciate the opportunity to be here. As Jeff had mentioned, I think there's a pretty good backstory here to start off from my perspective as well, and that is we did have the very first robot in North America at our site in Denver, and really to go back how that all transpired. I was paid a visit by Derek Brown and Jason Pells with the Carton Council of North America, and they had found this what looked to be promising technology in Colorado, up near Boulder, which was only about 10 miles from my facility. And they had asked me to go take a look at it and give me their opinions on it, and wanted to know if I might be, available to try it out. So took a trip up and met at the facility where Matanya Horowitz had a group of people that was working on this robotic sorting, and was pretty impressed. I guess right off the bat, looking at the prototype and then visiting with his group up there, there was really a few things that stood out to me. And one was that these guys are absolutely brilliant on a whole nother level, especially for me. Second, they had a genuine passion for, both their business, which is really artificial intelligence, and the waste diversion business, and knowing that there's areas of the business that needed help. And then third, after looking at the prototype, I was really concerned, actually. I was thinking, okay, how are they going to get to the pick rates we need? And how are they going to teach these robotic sorters how to do it and what to look for? Fast forward to today, and, Michael kind of covered a few pieces of it, but I think it's safe to say that the technology is no longer in its infancy stages. Speeds have typically surpassed a human sorter that, especially in all day long environment. Artificial intelligence is monitoring all materials, not just the one the robot is going after. And that's a huge component that I'm going to talk more about in a minute. But yeah, the artificial intelligence is there. It's learning. It's seeing several hundred pieces per second. And then, from my perspective, and I think there's a lot of other operators out there like this too, but we're on our second, third, fourth orders of these machines, which goes towards Michael's stats on the growth of this particular part of the business. Currently, I have about 11 robots with potentially 8 or so more that we're looking at installing. And I do also operate 2 standalone artificial intelligence units in one of our facilities. And that's the side, really, again, the artificial intelligence that's really exciting to me. Data in our business, it's been kind of hard to come by. Yeah, we know the inbound tons, we know the outbound tons we're selling, but knowing what's happening at every point in your facility, which is what this artificial intelligence is going to do for us, I have no doubt about that. Knowing that data for me is really key. And then also, knowing the data of the inbound material better, which we all struggle with, I think. Yeah, we do hand sorts and pull stuff and do those audits, but I think you're going to see that standalone artificial intelligence be available to really monitor that inbound stream, not in the not too distant future, actually. You know, the one thing I would tell people that are looking at the technology is, I would say, don't expect it to be perfect. It is improving every day. It's literally getting better every second of every day. But you know, I'll give someone a tour to look at a robot, and they'll say, well, it missed some items. Well, yeah, it's going to miss a few items, but it's going to pick a lot more than it misses. And you know, like I said, it's learning every day. So we're nowhere near the ceiling of what this technology can do. You know, just based on what's happened since the very first robot we installed in 2016 in our Denver facility to today, it's pretty amazing. On the robots I have 8 of them on fiber, and the rest are on plastic. So I kind of have a good mix in how they're operating. The other point I'd like to make is you know, the tech it's around that 80, 85 picks per minute, and that's obviously very fast. You really have to look at the effective picks per minute, right? What it's actually picking. Again, this goes back to, it's not perfect, but let's say it's missing 20%. So you're still getting between 65 and 70 picks per minute. But again, that's all day long. And that's in a position where, like Michael had said, it's hard to find somebody just to do it. So it's a really great alternative. And it's also something, though, you have to really monitor. It's like any other piece of equipment in these facilities. You have to monitor how you're feeding it. So that's you know, something that we've learned over time. You have to. It's a no-brainer in our facilities is how you feed materials, but yeah, it's really important that you make sure that stuff is spread out. So yeah, that it's improving every day. It's not perfect, and when people look at it, they're thinking it's going to be perfect. So just wanted to make that point.
Brent, we got 2-minute warning, Brent.
2 minutes. Okay. So with our facilities, right, these machines are filling a job, like I mentioned, that you can't find. You can't find people to do it. Michael mentioned it. I like my operators in each facility to focus on the equipment and making sure things are maintained correctly. And when they're trying to find people for jobs, that's a full-time job in itself. So the robots really do come in handy when you put them in place and not have to worry about filling that role, if that makes any sense. I definitely need to mention that the Carton Council was instrumental. I mean, obviously, I mentioned they were the first to really come to me about this. But it was really because of them, Derek and Jason, that you know, this came about for me, and it's been a nice addition. And you know, we've been a benefit of a grant or two from them, and it's been nice. But there's all kinds of other grants out there for these machines as well. The waste stream, you know, it's changed quite a bit. Everybody knows this. It's not anything new. We haven't been dealing with for the 25 years I've been in the business. These machines are able to see that and give us reports on how the stream is evolving. That artificial intelligence piece, again, is pretty huge for me. And with that, I think I'll just, I'm probably right at my 10 minutes, so I'll look forward to questions later on.
Brent, thank you.
Yep.
That was great. Yeah, again, any questions, put them in the chat box and we'll address them at the end. Our next speaker is Tim Dewey-Mattia, and he is the Recycling and Public Education Manager for Napa Recycling and Waste Services. Yeah, I met Tim at CRRA conferences over the years, and really enjoyed talking to him and learning and getting his insights as a small MRF operator in Northern California with a real mission-driven approach. And so I've always learned from Tim and love hearing what he has to say. And they operate a few robots now as well. So with that, I'll hand it over to Tim.
Great, thanks, Jeff. Thanks for having me, and thanks, CRRA, as always. And I think Tracy's going to run my slides, so I'll direct from here. So, yeah, Jeff gave a brief intro. We do everything except have a landfill. So we're, a kind of a moderate-sized facility. Our facility, a lot of folks are familiar with, but we'd love to show it off if anyone's coming on a tour. We talked a lot about the upgrades we made on our organic side recently, but this is actually kind of focused on our recycling end of things. We are a city-owned facility. We're the private operator. We're also the hauler in the region, in Napa, and then we also bring a material from the surrounding region. So we kind of we see the material from the beginning right to the processing end. So I think we have a good view on that. And then on the MRF end, in the last 5 years, with all that turmoil that we talked about before, we've had to put in a lot of upgrades because of the changing material stream, and that's for cardboard, plastics, and then adding in technology. So we've added conveyors, we've added an eddy current, additional magnets, and then 2 robots as of now. We're looking into opportunities for hopefully a 3rd one coming up, and then we also have optical sorting for our paper. So we'll focus on the robots, but I think it all kind of ties in together because, it's not and/or with manual sorting or kind of mechanized, it's kind of both for us. So talk a little bit about that. You can go to the next slide. And that's just a picture of our facility. You kind of see it's a small facility. We're on, 20 acres, but, most of that's devoted to the organics. And our MRF was, built originally in the 90s and then upgraded to single stream in the early 2000s. And we've actually had to push it out. Like if you come in our MRF, you'll see we start outside now with a conveyor on the front end. And then we've actually added sort of these snaking conveyors that go out the door, and our robots are outside next to our compost piles underneath the roof. So we are dealing with wind and other kind of things, and it's we've got it working, but those are additional challenges that you have to look at if you're trying to add stuff in. Is where does it go? Because we're on sort of limited footprint. So I can go to the next slide, but that was actually a something that we've had to deal with. So one of the things we talk about with our recycling is obviously there are so many issues with contamination. This is our in-mold graphic that goes on our carts, right? We've gone to simple pictures. We take cartons we have for 20 years, our other typical recyclables. But with our sorters, we used to have about 20 to 25 sorters we have working in our MRF, and half of their labor is removing contamination. So we were seeing, we see 6 times as much film plastic as we did 15 years ago. And so that material, we're spending more and more of our hours on removing the stuff we don't want, and it was harder to get the stuff that we do want. And so we found that adding in the robots has helped robots focus on the stuff you do want after the humans are removing stuff you don't. And that's really how we've had it set up. And we've added optical sorting for our paper as well. And we've sort of been able to capture more of these items in this picture because of that. And one of the things about having robots is that we've been able to get data. We didn't really know that much before about what we were actually capturing. And this has helped us get more information. We're watching things more on the line. As we've added additional ways to sort things, you kind of find out more about it. And then, of course, if you have more of a commodity at the end, you know that you were missing some of it all along. And that's kind of what we found. We didn't realize that we were missing so much PET or HDPE or cartons, for that matter. And then until we had the robot kind of layered onto that, and we realized that we were getting that much more. You can go to the next slide. That was actually a really important thing. And so when we worked with the Carton Council and we got a grant. We actually have 2 robots. Originally, we had a robot. We were doing just plastics. We got partially funded to add the second one, the AM robot. God, I don't remember how many years ago at this point, but that is also pulling cartons partially, and then plastic bottles, HEP and PET. And one of the things about these robots is that you'll notice this in MRFs is you need to have redundancy. We used to have one person pulling cartons, right? That was it. And if they missed it, it didn't get caught. And you had human sorters pulling the plastic bottles. And we have our, the way our line works is we have our container line where we still have sorters pulling plastic bottles, other commodities. Then we have the magnet, then we have the eddy current. And so it shows up at the very end, and you can go to the next slide here to see this, is that we're basically at the very end, the robots are there. And I think that's actually helpful. It was mentioned, I think Brent might have mentioned this, is how you present material to robots really matters. So if you look at the beginning of the MRF and you have these big piles of cardboard and film plastic and bagged stuff, the robot would not be able to handle that with its little suction cup, no opposable thumb thing. So you really have to work on the infeed, and having them at the end has helped us remove all this stuff that would cover it up. Because right, if that plastic bottle is covered up with cardboard, the robot can't grab it. And so this is how it kind of shows up into the robot. And you see, what you see there is you see a lot of the contaminants, like the diapers and the rocks and the potatoes, but then you'll see cartons and PET kind of as well. And so it's a lot easier for it to work. And that it becomes a learning process for the robots as well. And we also have, we have another person after the robots to kind of catch the stuff that was missed. So along the line. So you have this sort of different places to capture stuff that was missed. And you have people are good at certain stuff, robots are good at other things. And we, you know, obviously we haven't had such bad issues with labor that we haven't been able to, you know, operate, but it's really hard to hire folks. And so if we can keep the good employees doing things that is really good for human sorters, and then kind of some of the more dangerous stuff and some of the stuff that's better for machines, then this has kind of worked out pretty well. You can go to the next slide. And so one of the things, you know, this is cartons, obviously we do HEP and PET as well with our robots. With technology, one of the things that we never really expected was, so we added an eddy current. We never had an eddy current. We used to hand sort aluminum. And at about the same time, a couple years ago, we added in the eddy current. And obviously that's pulling more aluminum, but we didn't, you know, kind of on the carton end of things, it pulls a lot of our aseptics. And this is something we had no idea would happen. But because it's like such a strong, you know, kind of reverse magnet, and that aseptic carton has, you know, some percentage of aluminum in it, it pulls them. And we've actually added a conveyor after our eddy current to sort cans from aluminum foil, from other non-ferrous metals and aseptics. And we were getting all this additional aseptic cartons that, in particular, when it was being hand sorted, those were not things that were getting targeted very much by a human sorter. But we've actually got this other side. And so we've been able to add more aseptics into these piles and bales than we ever were able to before, sort of a side benefit, as you didn't even realize that you get when you're adding in these additional machinery to go with your human sorters. And it's always like interesting in a MRF because we're always kind of tinkering with how things move and conveyors going all different directions. But having these capabilities of technology has helped us to really to capture more stuff and then to focus on really cleaning stuff up and capturing other fragments of this recycling stream that has value, but we haven't been able to capture before. So yeah, next slide. And the one thing, you know, we've been able to do is with our partnership with the Carton Council, obviously, is we have this milk run, MRFs in the Bay Area. We'll go and we'll pick up, you know, non-full loads from them. Because one of the things that we see with when you are able to use robots or other technology to sort stuff that you never were sorting before, it's a lot of these things are not the high volume things like cardboard, paper, PET, HDPE, and you have storage issues on MRFs and also obviously like issues in finding buyers, in particular right now, being able to move loads. And nobody wants to have loads of any commodity sitting on their site for 6 months. So this milk run, which we're running for milk for cartons, you know, we're thinking that it has opportunity for polypropylene as well and other materials that I think you're going to see get targeted by robots and other things, because that's a commodity that has value, that the industry is interested in having get captured. And we might not have been able to focus with having a sorter do it because it's just not a volume that you can have one person pulling. But if you can have a robot that pulls 4 different commodities, and one of those is polypropylene or cartons or some other type of material that has a little bit of value, then you are able to kind of do it, and then we can set up a whole infrastructure. So I think this is a scalable thing. Yeah, go ahead, Jeff.
I didn't want to interrupt you there, and you thought you're at 1 minute.
That's about it. I think the next slide was just, hey, please come for a tour, contact me, and happy to have this discussion. Thanks for having us, and that's it.
Thank you. Yeah, again, any questions for Tim, put them in the chat box. Appreciate it, always. So our next speaker is Adam Schaefer, and he's the sales director for the West Coast for AMP Robotics. And, you know, AMP you know, as Carton Council, we're agnostic, but just stating fact, AMP has been the leader in the development of this technology and the vision, going back to when they were 2 or 3 guys and a dog with a prototype. So obviously they should take credit for a lot of the development here. And with that, I'm really interested in, you know, hearing what Adam wants to share. So take it away, Adam.
Hey, thank you, Jeff, and thank you to the rest of the presenters. You guys all teed me up nicely here, but got the screen sharing here, so let me go ahead and roll through this. But we are AMP Robotics and are excited to take some time today to talk to you guys a little bit about what we're doing to apply artificial intelligence to really modernize the recycling infrastructure. And if we start by kind of taking a look at, you know, what are some of the fundamental challenges that we face in the industry today, you know, obviously material recovery facilities, you know, serve as the hub of recovery for all types of material, right? And if we look at the United States, for example, there are thousands of municipal recycling programs nationwide that are really collecting materials generated by millions of people. So, you know, between the collection and actual recycling of the commodities, there are really actually a small number of MRFs. Thus, these facilities are somewhat centralized material hubs. And if we look inside those hubs, you know, one of the major challenges in the industry is that MRFs incur these high costs when attempting to sort out commodities, especially as these products continue to evolve and become and have complex form factors and different material compositions. So today's MRFs really require a tremendous amount of labor to do the manual sortation, and as a result, may incur high residue loss, and they continue to face challenges that help ensure high bale quality and purity levels. So the problem is that, you know, in a nutshell, is really that the value of these commodities is often being eroded by the high cost of sortation. So relying on manual labor means that MRFs will, you know, continue to face ongoing struggles with labor shortages, turnover, and health and safety risks.
Hey, Adam, can you turn your video back on, or your camera?
Yes, I sure can. So looking at those challenges, you know, at AMP, we've really made it our mission to develop cutting-edge technology to really help drive down the cost of sortation and provide the tools necessary to really improve operational efficiencies and to ultimately elevate the recovery rates of these high valuable commodities. And this is really all made possible by using data-driven approaches to automation. Here. So the Carton Council obviously has been instrumental in improving and expanding carton recycling by providing grants to several facilities for installing technology such as robots. And we've been a proud partner with the organization. Looking back, you know, they've helped provide funding, as Brent mentioned, for AMP's first robot at Alpine Waste and Recycling, now GFL, in Denver. Predates my time at AMP, but Brent, who previously spoke, was one of the first people to trust his business to our technology back in 2015. The Carton Council, as you heard, has also helped fund robots for Napa recycling, as well as our first robot installed at Single Stream Recyclers down in Sarasota, Florida. SSR, as an example, has now moved beyond that single Carton Council funded robots and has installed 14 other robots working on a number of applications throughout their facilities. We have robots working on fiber lines, container lines, quality control stations, as well as residual lines to pull any last commodities of value prior to landfill. So in addition to cartons, we can obviously use this technology to process plastics, paper, cardboard, metals, and other materials. So we truly do owe a debt of gratitude to the Carton Council for really helping us get our robots into some of these key facilities early on. So if we fast forward to today, it was really that early grant funding and support that has helped propel AMP's organization and really commercialize the robotic technology and scale us through broad adoption. We now have over 170 systems installed spanning 3 continents and internationally and across more than 25 states here domestically. Most of our installations are in single stream recycling, but we do also have applications for organics, e-scrap, and construction and demolition. We, again, are scaling rapidly. We now have close to 200 employees and 3 facilities across the greater Colorado area. So to take a look at how the technology works, we've really developed a high-speed, intelligent robotic sorting system that has 3 main components. And the best way to think about it is kind of the brain, the eyes, and the arms. The system's computer vision, which is the eyes of the system, identifies materials that comes down the conveyors to be picked or sorted, just as a human would. The brain, which is our AI platform, that converts those images into data, right? That's where we begin categorizing everything that the camera systems are recognizing. The AI, the artificial intelligence, then really guides a Delta-style robot, the arms of the robot, to pick and place those materials to be recycled. All of this happens at superhuman speed. We have applications where we're performing 80 to 120 picks per minute compared to the pick rates that are sustainable for human sorters. And we do so with consistent precision and extremely high accuracy. So all of the data that we capture, as you heard earlier, can then help solve some of the toughest challenges that are out there in recovery today, including where valuable material is being lost in an operation, where downtimes and inefficiencies are in an operation, and where and why certain bales may be being rejected due to purity concerns. So very powerful data that this artificial intelligence captures as well. So here's a look at our robotic sorting system called Cortex. These systems offer MRFs really the ability to and flexibility when faced with changing recycling streams. So as you heard earlier, these can target a significant amount of different material types. So as we see seasonality and waste changes or challenges such as COVID and volume shift from clean material to contaminated material, robots are there to handle that, and they operate more consistently and reliably with fewer people, obviously, which helps us combat some labor challenges. The Ampvision system, again, this is the eyes. This is available as a standalone modular system, as Brent had mentioned that he's got a few in his facility. These can strategically be dropped into a facility's existing operation and really provide you data collection anywhere from residual lines to quality control applications to container lines to paper and fiber lines to give you some data where you may have to be doing some manual audits today. And the real beautiful thing about artificial intelligence is that it can handle the most challenging materials, right? Historically, a lot of these materials have been hard for humans to identify or recover. Artificial intelligence helps solve that issue. These systems are very flexible. They allow the facility to change the targeted materials on the fly. And we've seen drastic improvements in this technology over the years. Not only helps the MRFs directly, but this also helps the industry adapt to changes in state policies, regulations that we are obviously we'll see in the future here.
Adam, got you about 2 minutes.
Sure thing. So Clarity, this is the data piece. This is the data capture and basically the portal, the user experience of the data. So every piece of material that passes under our vision system is captured and available in a portal that can be accessed to understand trends, get material counts, masses, set alerts on spikes, again, really to drive operational efficiencies and give you a look at the data that historically has been hard to capture in the industry. So here's a look at SSR down in Sarasota, Florida. Again, this began with one carton console robot, and they have now 16 arms working in their facility. They sort at speeds 2 to 3 times faster than humanly possible and are capable of operating 24/7 with these robots. Their accuracy is upwards of 98%, ensuring higher purity bales and more recoverable items for resellers. Worker safety is obviously improved, and it obviously takes significantly less people to run the plant. We can also manage spikes in material. The robots have cycle times, again, upwards of 120 picks per minute. So very efficient tools to implement and handle surges in different volumes of material. So, you know, the industry is really adopting this technology. You know, it's been adopted at a rapid pace, and we're working in collaboration with coalitions, you know, like the Carton Council, to help with capital outlays through innovations and purchase models, like financing as an example. So grants in conjunction with options like lease programs really do make this technology even more accessible to MRFs at all levels of the public and private space today. So we're excited about the journey we've been on. To see the scale and the advancements has been impressive. And I appreciate your time and happy to take any questions later in the presentations here.
Adam, thank you. So we do have a question, and I'm going to direct this to either Tim or Brent or both of you, since you're both on the front lines. The question in the chat is, the public is very sensitive to machines taking over their jobs. Can someone talk about job displacement due to these strategies? Brent mentioned workers focusing on other things besides sorting. So I thought Brent or Tim, if either of you want to share your view on the displacement or how you view it.
Yeah, I certainly can start off, but you know, that's a question we got, I'd say, a lot more very early on. There was a bit of a concern. Always a question is, okay, these are going to take jobs away from people. A couple of things, you know, that we would tell people that ask those questions are, one, every day in every facility, I probably have at least 5, sometimes up to 12 positions open I cannot fill. So, you know, these machines are really putting sorting in place where I can't fill a role anyway. So that's one side of it. You know, the other side is it was mentioned earlier in Michael's presentation from a safety perspective. You know, it'd be perfect if the stream coming in had everything that was supposed to be in there and nothing that wasn't. But unfortunately, that's not the case. So you do have safety issues like needle sticks, right? From a safety perspective, these machines are really safer to operate, and it's cutting down on those safety related items. But and then we have taken some people and shifted them from, if there was a robot put in where they were sorting, we've taken that person and put them in another spot that was open. So really, they're helping us be staffed, if that makes sense.
Yeah, and I would just add, I mean, it's true. You always want to be cognizant of worries over, you know, taking away jobs, but it's not, we talked about this, it is a dirty, unsafe job. And there are ways to make that safer. And I think one of those is trying to mechanize parts of it and, you know, having the humans doing work that may be safer or more specific, like that they're better at, and they are like, they're better at certain things. And then also kind of shifting the positions to more like, kind of tech focused, you know, kind of engineering, monitoring the machines. You know, we have folks doing other stuff that may actually help us in the long run, because those jobs may be more attractive to folks to work on than kind of the classic sorter position that is hard to fill and dangerous. So yeah, it's not either or. I think it's both. But particularly, you know, it's gotten to be less of a worry, and obviously specifically right now when it's hard to fill the decisions. But you kind of see it work out, and you bring folks, you bring elected officials or whoever, the public, in to see the operations, and they get a sense of where maybe it's not that big of a worry to have machines doing some of this work, because it's actually good for that, and have people do other jobs.
Thank you both. So we have about 3 minutes left, and I had to cut everyone off just to keep it moving. But of our 4 presenters, if there's anyone that has anything further or any other comments that came up that you want to share, jump in.
Well, I would like to just comment on that last comment, because I think it's a national phenomenon. The idea that the jobs that are being taken away, so to speak, haven't been filled for a long time. The average MRF complement for a 35-ton-an-hour MRF is 45 people, non-intelligent sorting type of MRF, and of that, only about 30 to 35 are going right now. If you talk to people, they're down 25 to 50% of their staff, and they cannot fill them. So in the case of MRFs, because we got to be cognizant, as the other speakers have said, these are taking away and making only the better employees who are sticking around and actually showing up to work. It's taking those places. It's not, people are not losing jobs. Hopefully that's helpful. But in this one case, the MRF environment is a hard place to work.
So 2 questions that came in. I know we've only got a couple minutes left, but I think they're both good questions. One is just about what is the maintenance like on these machines from a standpoint of daily, weekly, monthly upkeep. So we'll start there. Just whoever wants to quickly address that.
Yeah, and I'll chime in there. From a maintenance perspective, just like any piece of mechanical equipment, right, there is maintenance requirements. From a daily maintenance, typically at the end of each shift, we want you to do an inspection on the robots. We want you to inspect things like the gripper shaft, the gripper cup itself, the actual device that seals and grabs onto an object, make sure there's not tears, obstructions in the object. We also have you look at clogs or obstructions potentially in the shaft. Occasionally film plastics will get drawn up into shaft, and those need some manual intervention to be pulled out. From a weekly perspective, right, there's some blowing off of AC units that help cool our computer control cabinets. But fairly minor, a fully sealed system, a Delta style robot that's fully sealed. So fairly light maintenance, but as you expect with any piece of equipment, preventative maintenance actions do need to take place.
And Adam and Michael, this last question here, which I think is a good one. Is anyone using the technology for brand audits or tracking where waste is commonly coming from? And I guess they mean like a particular brand or industry.
Yeah. It's at its infancy, but I know of 2 cases where one I heard about yesterday from Eric Herbert of BHS that they got qualified. MRF has a brand going into a mill now that's qualified based upon the reports coming out of a robotic system, it's the second one I've heard of. The other one was a while ago, and it was on the East Coast. So that's I think you're going to see that in the future. I think you're going to see these, and I think Adam was speaking about it. You're going to see these robots going into the counting phase, and really, once they go into the counting phase, they're going to start integrating backwards into all parts of the plant, back into the motor control centers, and they'll be able to speed up, slow down, and optimize not only their station but stations before and after them through comparative technology from the vision element of the robots. Adam, that's for right now. That's all.
Yeah, and I would just add to that and share that, as the gentleman mentioned earlier, just like presentation and material is key to robot pick success, presentation of material to serve as counting or data for front end. So today we do have a lot of our vision systems, the Clarity and data portals, working in QC, pre-bail applications, understanding operational efficiencies. There is absolutely a use case for front-end audits and material studies. But again, the key to success there is that we've got to present material to those vision systems in the right fashion.
Yeah, I would just add, we've taught the robots to pick a couple of materials that producers had, you know, PET materials or whatever that it might not have known, but you can do that. And I think it's exciting to kind of think about the future because there is potential there.
Mhm.
Well, we're at our time. Thank you, everyone, for joining us. Thank you, Michael, Brent, Tim, Adam. Thanks for sticking with us, everyone. And with that, Tracy, unless you have anything else, I think we're done.
No, just that we recorded the webinar, so if you missed any part of it, we'll put it on the CRRA website. If you have any questions, let me know. But thanks for attending. Hopefully we'll have another one early in the new year.
Thank you.
Thanks, Jeff.
Thanks.
Thanks everyone.
Thank you.